All we're doing today is solving systems of quadratic equations. So previously we've solved systems of just linear equations. That's where we have two lines and we're trying to figure out where they cross each other, where they intersect. Today we're going to talk about where different quadratic equations intersect. So if we have, parabola intersecting a line or an ellipse intersecting another ellipse, things like that. So we're gonna solve for the solutions and where they cross each other. So today we have these two equations. We have a parabola here because it's one of them is squared, right? It's just the y that's squared and not the x. If I put this into standard form, it becomes x plus 9 is equal to y squared. So this is a sideways parabola that's opening up to the right. And then I have a second equation, which is just a line, right? Because all I have is x and y, and neither of them are squared. So I get that into the form of y equals mx plus b. This is a line with a positive slope. So I'm going to graph both of these equations on the same coordinate plane so you can kind of see where these are intersecting. So the first thing is that I plot the vertex of my parabola, which is at negative 9, 0. So that's right there on the x-axis. And then I'm going to go up 1 over 1, up 2 over 4, up 3 over 9, up 4 over 16. So that's how I would graph that first equation with the parabola. Remember that I'm always squaring the amount that I'm moving in the y direction, right, to move in the x direction, and that's how I get those other points. So next I'm going to graph the line. First, for the line, I'll graph the y-intercept, which is at negative 3, and I'm going to go rise over run, right? So it's up 1 over 4, up 1 over 4, and I would keep doing that. Now, I can see that this line is crossing the parabola one time, they're intersecting, but eventually I'm going to keep drawing this line forever and ever, and eventually it's going to cross the parabola again. So this is actually going to have two solutions. I can see that the first solution is 0, negative 3. That's the first place where they're intersecting. But how do I figure out the second place where they're intersecting? Well, for that, I'm actually going to use the method of substitution. So I'm going to take this first equation of the line, and I'm going to solve for x. So x is equal to 4y plus 12. And then I'm going to take this equation and plug it into the parabola equation, right? So I'm going to plug it in for that x. So I get 4y plus 12 is equal to y squared minus 9, which means that if I bring everything to one side, y squared minus 4y minus 21 is equal to 0, and then I can factor this into y minus 7 and y plus 3, which means y is equal to 7 and negative 3. So then lastly, I actually need the x coordinates of those solutions, right? So I'm going to plug in 7, so it's going to be x is equal to 4 times 7 plus 12, and I'll also plug in negative 3 separately, so I get 4 times negative 3 plus 12. And I end up getting x coordinates of 40 and 0, which I expected, right? The first point being negative 3 was that point that I already saw visually there, but I also have the point 47. Okay, so you don't need to actually draw these graphs in order to figure out where they're intersecting. It might be helpful to you, but you can also do it completely algebraically without any type of graph. So we're going to take a look at two ellipses that are going to be crossing each other, or rather one is an ellipse and the other one is a hyperbola. So we've got these two equations that have x squared plus 2y squared equals 12. I know that's an ellipse because of the plus sign. Second one I know is a hyperbola because of the minus sign. The first thing I'm going to do is I'm going to solve the first equation for x squared. So x squared is equal to negative 2y squared plus 12. And I'm going to plug that into x squared in the second equation. So I get 3 times that quantity minus y squared equals 8. And then once I distribute that 3, I have this here. And I'm just going to combine my like terms, the different y squareds. I'm going to subtract 36 from both sides. I end up with y squared is equal to 4 and y is equal to plus or minus 2. However, I am not finished because I also have to solve for x. Once I find y, I have to solve for x because this is going to give me two different points. Okay, so I'm going to plug in positive 2 first, but what I realize is that negative 2 or positive 2 is going to result in the same solution for x, right? Because 2 is squared, right? And negative 2 is squared. So negative 2 is 4, and so is positive 2. So then I end up getting x squared is equal to 4, which means x is equal to plus or minus 2, which means I actually have 4 total solutions. I have negative 2, 2, negative 2, negative 2, 2, 2, and then 2, negative 2. So you can do those kind of slowly. You basically just match each of the x coordinates solutions that you found and match them with each of the y solutions that you found. And they were interchangeable because when I square 2 or negative 2, it ends up as the same number. So lastly, I'm going to show an example with an inequality. Suppose we have 4x squared plus y squared is less than or equal to 16. This is an ellipse because both are squared. They're scaled differently, so it's not a circle. And I know that it's not a minus sign, so therefore I know it's an ellipse. So I'm going to get x squared over 4 plus y squared over 16 is less than or equal to 1 once I divide both sides by 16. I'm also going to divide the second equation by 16. That one is also an ellipse. I'm going to graph both of these ellipses to show where the solution is, because remember, if it's inequality, I actually have a range of solutions rather than just one or two solutions. So I'm going to draw my range of solutions by graphing each of these inequalities. So first the purple one, I know that I'm going 4 out in the x direction and 2 up and down in the y direction. So I'm going to draw that circle, and I'm going to shade inside of it because it's less than or equal to 1, right? So I'm graphing the region that is less than or equal to this shape. So then I'm going to graph the other one, which is 2 in the x direction and 4 in the y direction. I'm going to also shade inside because it's a less than or equal to sign. Then I just look at where these two regions are overlapping. You can see it's right here in the middle. This is our overlap and our solution to the equation. Good luck on your homework and have a great day.